All right, this section deals with insulin resistance and dyslipidemia. And dyslipidemia is just a fancy term for a normal amount of fat and or cholesterol in the blood. So this really talks about the linkage between type 2 diabetes, people with hyperglycemia, and how it affects your cholesterol levels and your LDL levels, so and HDL levels. So it's important to make that linkage. So dyslipidemia and the insulin resistance syndrome is characterized by three things that we're going to see in the next slide with the pathway. But notice we're talking about elevated total triglycerides, VLDL triglycerides, a reduced good cholesterol, the HDL cholesterol, and an elevated small dense LDL cholesterol. So these are the three things that individuals with insulin resistance, type 2 diabetes may have. And here's a pathway that illustrates how these three things come about. So again, this is the mechanisms relating insulin resistance and dyslipidemia. So keep in mind as we're talking about this that, again, steps 4 here and 5, 6, they could go in any direction. When you're looking at this VLDL, it could go in any direction. But for teaching, you just got to pick a direction and go with that. But just know that it could go either through HDL or to the LDL. But we start here with insulin resistance in the adipose tissue, and that's going to cause an increase in free fatty acids. Well, the increased amount of free fatty acids making its way to the liver is going to cause an increase in VLDL triglycerides to be made, because the liver says, hey, I got more free fatty acids coming in, more triglycerides, I need to do something with them, and therefore I'm going to make more VLDL triglycerides, along with the ApoB that corresponds to the VLDL. Well, now you have an increased VLDL in the blood. What happens here is that you're going to have an interaction between VLDL and HDL in the blood via the protein CETP, cholesterol ester transfer protein. So if you remember before, you have CETP stands for cholesterol ester transfer protein. And what this does is it causes VLDL to give up its triglyceride to HDL, and HDL to give up its cholesterol to VLDL. And people might think that this is a good thing. However, when HDL is rich in triglyceride, this reduces its ability to pick up cholesterol. And it's also more susceptible to becoming broken down. As we see in step 5, as it returns to the liver, hepatic lipase will actually separate the ApoA1 from the rest of the HDL. And what happens is ApoA1 then will be excreted in the urine, and it removes any ability for the ApoA1 to be recycled and made into, combined with a new HDL to make a new HDL lipoprotein. At the same time, now that the HDL has lost its ApoA1, hepatic lipase has an easy time to break it down. So now we've talked about an increase in VLDL triglyceride and a reduction in the good cholesterol HDL. And the third had to do with an increase in small dense LDL. Again, how do we get there? Well, VLDL and LDL will interact via CETP. VLDL will give up its triglyceride to LDL, and LDL will give up its cholesterol to VLDL. An LDL that's rich in triglyceride will make its way back to the liver, and via lipoprotein lipase and or hepatic lipase, that will change the configuration and the content of the LDL and make it a small dense LDL. And this will cause an increase in coronary heart disease. So we have three things that happen: an increase in VLDL triglyceride, a reduction in the good HDL, and an increase in small dense LDL. Now, why is small dense LDL so bad for us? As we make our way to that, here again are the words of what we just talked about. Again, just make sure that you put these steps in your own words, making sure you have a good understanding of them. All right, so let's talk about the small dense, why it's so bad for us. Well, there's three reasons why small dense LDL has a stronger association with cardiovascular disease than the larger HDL. If you remember back to lesson 3, we talked about the different subfractions or sizes of LDL. You have a large LDL and small LDL, or small dense LDL. Well, the reason small dense LDL is so bad for us is that it remains in the blood longer, and therefore, if it remains in the blood longer, it has a greater opportunity to cause damage to the tissue. At the same time, it can more easily enter the intima of the coronary artery, causing atherosclerosis. And finally, LDL can be more easily changed into a modified LDL. So again, this kind of summarizes the same thing about how you have, these are the 3 things of which why a small dense LDL is so atherogenic. At the same time, so these things are going to lead to an increase in insulin resistance syndrome, or the metabolic syndrome that you may have heard about. And also it's going to be associated with high triglyceride and low LDL. So these are things to keep in mind as to why small LDL, or small dense LDL, is much worse for us than overall, or the larger LDL. So make sure that you have a good understanding of this pathway, pausing the video, writing the steps in your own words, and then comparing them to the rest of the notes here. You can also practice on Blackboard, putting these steps in your own words, or putting these steps in proper order as well. There's one other thing to be aware of after you've practiced that, is what happens with people who eat a large amount of simple sugars in their diet, because most people will think if I eat a low-fat diet, then I'm okay. But carbohydrates can actually, simple sugars can increase the amount of dyslipidemia in a person. And the way it does that is simple sugars is going to cause the liver to make an increased amount of VLDL triglyceride. So simple sugars in the diet cause the liver to produce more VLDL triglyceride. At the same time, when you have more VLDL in the blood, it's going to cause the VLDL to remain in the blood longer. And by doing so, the simple sugar diet will upregulate CETP, allowing for that exchange to occur between between VLDL and HDL, and between VLDL and LDL. And therefore, you have a reduction in HDL, but you also have now an increase in the small dense LDL. So these are, again, the summary of that pathway as to why a simple sugar diet can cause increase in VLDL triglyceride, why it can cause a reduction in the HDL, and also an increase in the small dense LDL. So when you're working with clients, it's important to understand not just for them to reduce the high-fat diet, but also reduce the amount of simple sugars in their diet as well, because that can lead to dyslipidemia. So make sure then that you have a good understanding of this pathway as to what happens with a simple sugar diet. And just as a review, dyslipidemia is going to be, and diabetes is going to be caused by an increase in triglycerides, VLDL, LDL, and small dense LDL, and ApoB, which are associated with VLDL. And it's going to decrease the amount of HDL and ApoA1 that's associated with HDL. So at this time, make sure that you have, again, you review the putting these steps in your own words, making sure you do the practice on Blackboard. Once you feel you have a good understanding of these steps, then you should move on to the thinking review questions at the end of this lesson here. What would happen to triglyceride, small dense LDL, HDL, and coronary heart disease risk with the following? Again, practice this, write these down as in the rationale, and then compare to the notes. That I'll have a video for walking us through how the answers to each of these.